Sharpness of resonance. Here graph between I and omega is shown. As we have got Z equal to a root of R square plus XL minus XC whole square. For resonance, XL minus XC equal to 0, from where we get omega equal to 1 upon root LC. Now, current I0 will be E0 upon Z. So here graph between omega and I0 is plotted. For low value of R, I0 will be high. For moderate value of R, this is the graph. For higher value of R, this is the graph. So at resonant frequency, the peaks are shown. Now we define a factor called quality factor that measures the sharpness of resonance. It is defined as resonant frequency divided by bandwidth. So resonant frequency, angular frequency omega r divided by omega 2 minus omega 1, which is equal to omega r divided by twice of delta omega. Here, this is omega 2 and this is omega 1. Omega 2 equal to omega r plus delta omega, and omega 1 equal to omega r minus delta omega. At these angular frequencies, maximum current reduces to root 2 times. So at omega 1, maximum current is I0 divided by root 2. At omega 2 also, it is I0 upon root 2. And when omega is equal to omega r, current is maximum, it is I0, which is E0 divided by. So quality factor, Q factor in LCR circuit is defined as the ratio of resonance frequency to the difference of its neighboring frequencies, so that their corresponding current is 1 upon root 2 times the peak value. So the difference between these two frequencies is called bandwidth, and bandwidth is equal to W2 minus W1, which is 2 delta W or 2 delta omega. Now, so bandwidth omega 2 minus omega 1 equal to 2 delta omega. Now we are going to see the expression for quality factor. So as we have seen that at resonant frequency, Z equal to R, and at other two frequencies, at omega 1 and omega 2, we have seen that current reduces to root 2 times. So corresponding value of Z must be root 2 R, because I will be E0 upon Z. When Z equal to R, then I0 will have maximum value. And when I0 reduces to I0 by root 2, it means Z has changed to root 2R. Here Z equal to R. So let's try to derive the expression for quality factor. So we know Z equal to the root of R square plus XL minus XC whole square. So XL is omega L minus 1 upon omega C square. And as we have seen, it is equal to root 2R. So we can square it. So it will become R square plus omega L minus 1 upon omega C whole square equal to 2R square which implies omega L minus 1 upon omega C whole square equal to R square, or omega L minus 1 upon omega C equal to plus minus R. Now we assume omega 1 to be minus R and omega 2 corresponds to plus R. So let's write it: omega 1 L minus 1 upon omega 1 C equal to minus R, and omega 2 L minus 1 upon omega 2 C corresponds to plus R. Now, if we add these two, so on adding, suppose this is 1, this is 2, on adding minus R and plus R will cancel out. So we will get omega 1 plus omega 2 times L minus 1 upon C, then it will become 1 upon omega 1 plus 1 upon omega 2. So we can take LCM. So omega 1 plus omega 2 divided by omega 1 times omega 2 equals 0. Now, from here, we can remove omega 1 plus omega 2. We can divide each term by omega 1 plus omega 2. So what do we get? We will get L equal to L minus 1 upon C times omega 1 omega 2 equal to 0. Or, so let's write it clearly. We will be left with L minus 1 upon C times omega 1 omega 2 equal to 0, or omega 1 omega 2 equal to 1 upon LC. Now, if we subtract the two equations, that is omega 1 L minus 1 upon omega 1 C equal to minus R, omega 2 L minus 1 upon omega 2 C equal to plus R. If we subtract these two equations, then what do we get? So on subtracting, we will get omega 2 minus omega 1 times L. Here, first is subtracted from second. Omega 2 minus omega 1 times L plus 1 upon C times 1 upon omega 2. So we are subtracting, so this will remain 1 upon omega 1 minus 1 upon omega 2 equal to, it will become 2R. So omega 2 minus omega 1 times L plus 1 upon C times omega 2 minus omega 1 divided by omega 1 omega 2 equal to 2R. So from here, we can take common omega 2 minus omega 1 L plus 1 upon C omega 1 omega 2 equal to 2R. Now, here we have got omega 1 omega 2 equal to 1 upon LC, or 1 upon C if we evaluate from here. 1 upon C will be L times omega 1 omega 2. So in place of 1 upon C, we can put that value L omega 1 omega 2. So we will get omega 2 minus omega 1 times L plus L equal to 2R, because omega 1, omega 2 will cancel out from here. So we have got omega 2 minus omega 1 times 2L equal to 2R. So I'm erasing it. Omega 2 minus omega 1 times 2L equal to 2R, from where we get omega 2 minus omega 1 equal to R upon F. Now, if we go back to the definition of quality factor, it was omega R divided by omega 2 minus omega 1. So we put the values omega R divided by omega 2 minus omega 1. We have got R upon L. Omega R times L divided by R. Now, suppose we multiply each term by IRMS into IRMS. So this will convert in terms of voltage. So if you remember, XL equal to omega L. So here the same thing is written corresponding to resonance value. So omega R times L will become XL. So we can write XL times IRMS divided by R times IRMS, which will be equal to voltage across inductor divided by voltage across resistor. So in case of resonance, voltage across voltage across inductor and voltage across capacitor are same. So we can say that quality factor equal to voltage across inductor or voltage across capacitor divided by voltage across resistor. That is also called voltage magnification. Now, we know that angular frequency at a resonance is 1 upon root LC. If we square it, omega R square, we will get 1 upon LC. So this will give omega R. We take L here and we shift 1 omega in denominator, 1 upon omega C. So now in case of omega RL, we can write 1 upon omega C. So what do we get? Then quality factor Q will become 1 upon omega R CR. Here, this term leaving IRMS, we are going to replace omega RL by 1 upon omega C. So here it will be 1 upon omega C. So all three terms omega R CR will be in denominator, and this can also be written as 1 upon R times root of L upon C. So this is expression for quality factor. Thank you for watching.